So today we're going to look at solving absolute value equations. Again, an Algebra 1 concept, something we would have done. Evaluate expressions with absolute values, did that in elementary school. And then equations, that is a Algebra 1 concept. Absolute value is a number's position on the number line, represented by this absolute value. What absolute value is the distance from zero. Doesn't matter if it's 5 places to the right or 5 places to the left, it's 5 places from zero. So that's what we mean when we talk about absolute value. How far is it from zero? So we could get an answer where there's no solution. We call that an empty set with either just a set with nothing in it or this little zero with a slash through it. And we can also get what's called an extraneous or extra solution. Sometimes we do everything right, but it doesn't fit the conditions of the problem. It just doesn't work. It's inherent to the restriction of the problem, and it doesn't work. Okay, we'll see that. We'll practice it and see how it works. Let me just remind you again what I said a moment ago. Like the absolute value of 4 is 4, and the absolute value of absolute value of negative 4 is 4, and positive 4 is 4. So absolute value is 4, because how far away is negative 4 from 0? 4 units. How far away from 0 is positive 4? 4 units. Doesn't matter. It's 4 units away. So that's what we're talking about. So this is just kind of a blah, blah, blah. That's why I've just left the problem up here, because they asked us to evaluate this if x is 4. So we put the 4 into place, because this is just the original problem copied. Put the 4 in the place of x, and then they did inside, it's almost like grouping symbols, parentheses, whatever you want to call it. So we work in here, we do the multiplication first, right? Before we do subtraction, then we do the subtraction. Then we do absolute value. I've had students who want to do the absolute value first. No. If there's stuff in it, deal with it. And so that's what we've done. Then what's the absolute value of negative 2? It's positive 2. And what is 2.7 that we've been dragging along with us plus the 2 that we just got? That's 4.7. So this one I'll do real quick. So it's 2.3 minus the absolute value of 3 times 2 minus 10. So that's 2.3 minus, remember we're working inside the brackets. So what do we do first? The multiplication and subtraction. The multiplication. What we do next? We work inside the absolute value. Before we do anything absolute value, we clean up all the junk that's in it. Then we can see what we're taking the absolute value up. So that's 2.3 minus, right? Because that's a minus sign. It's outside. It has nothing to do with the absolute value. It's outside the absolute value. And what is the absolute value of a negative 4? 4. What is 2.3 minus 4? Negative 1.7. All right. So in Algebra 1, we would have done this. I just wrote it up here because I want to remind you. If we have an absolute value equation, we have 2 cases. Because what we don't know is if the thing in here that's equal to 3, we don't know if it's a 3 or a negative 3. We don't know. So the way that I teach students to do this is when you have absolute value equation, it's case 1, case 2. So you copy without the absolute value, see, copy without the absolute value. Then you recopy, but change the sign of the number on the right side. When it's in this form, that's what you do. So let's look at this down here, because that's what we're doing. So we have an absolute value equation. So we don't know if what's inside here is a positive 3 or a negative 3, but we take the absolute value, we get 3 either way. So it's a case 1, case 2 scenario. So what do? We copy without the absolute value. Then we recopy, but change the sign of the number on the right side. That's what we do. Then we're subtracting 2 and subtracting 2, and those are our 2 answers. I wrote them as a set because x could be negative 5. Look at it. What is negative 5 plus 2? Negative 3. Absolute value of negative 3? Positive 3. X could also be 1. What is 1 plus 2? 3. What's the absolute value of 3? 3. So that copy-recopy is a key piece to this when you have absolute value equations. We learned that in Algebra 1. Okay. So here's one for us to do from scratch. So do you agree this is an absolute value equation? It's an equation with absolute value, yes. So that means we have to do case one, case two. I couldn't tell you how many times that I've done this, went through it, worked it out over and over and over again. Get somebody's quiz or test paper and they didn't do case one, case two. It's just, you gotta do it, it's what it is. And so case one, I copy without the absolute value symbol. Case two, I recopy, but I change the sign to the number on the right side. It's just what we do. Then we subtract 3. And we subtract 3. And I'm going to write that in set notation, 11, and 5. Those are my two answers. That's my two answers. So, you can see, negative 11 and 5. That's what I got, right? Yes, negative 11 and 5. Okay? So, same thing here, case 1 and case 2. It's an absolute value equation. That's just how it works. Shortcuts get you in trouble. I like them. You know, they're fun when you can do them, but they get you in trouble. So this is 2x plus 5, copy without the absolute value. Then recopy, but change the sign to the number on the right side. So then I'm subtracting 5, dividing by 2. Subtracting 5, divide by 2. It's a negative 10. So those are my two answers, and if that is correct, then B is our answer. B is our answer. And we could check those by plugging them back in like I did earlier. You certainly would want to do that if it was an important situation, you know, quiz, test, stuff like that. All right, so we have this problem here. So one of the things that's different from this problem than the ones we just did is all the ones we just did had absolute value equal whatever. That one don't. It's got an absolute value plus 5 equal whatever. So I think the first thing that we should learn to do is isolate the absolute value, like get it there by itself. And we would do that by subtracting 5 from both sides. Now, I'm going to stop before I get any further, and I'm just going to look at that and I'm going to go, no. You cannot take the absolute value of anything. I don't care what that thing is right there. I don't care what it is. You can't take the absolute value of it and get a negative 5. It doesn't happen. It doesn't work that way. Absolute value is always positive, right? So you can't do that. So guess what the answer is in this one? Empty set. It just is. That's just what it is. Now, they did the work like I did, and then they said, this sentence is never true. It doesn't work. It can't work. It's not possible. You can't do that. So, can't do that. If we do this one, I'm going to see, because you subtract 7 from both sides. Now, watch out. I don't want you to get confused, because then you get to thinking all of them written that way are going to be empty set. Not necessarily, because things can happen to us, like this one right here. So if I want to isolate the absolute value, which is what I've told you you should do, then I'm going to put the 5 over here. If you add 5 to both sides, you get 2. That's possible. Absolute value could be 2. That's a case 1, case 2 thing that I would need to finish working. Yeah, it could happen. That's real. But not that equal to negative 7 or that equal to negative 5. No. So let me go on and go here. In the beginning of this problem, first of all, it's an equation with absolute value. And the absolute value is isolated. It's just that the right side is a bit more complicated than we're used to seeing. Would you agree? A bit more complicated. But if we follow the process, and you know, it's one of the things I pounded in Alg2 1, is the process. The process is important. You learn the process. You follow the process. Like baking a cake, there's a recipe. You get it wrong, you get it wrong. You get it right, you might like the cake, you know. And so here, we already have it isolated. So what I'm going to do is case 1, case 2. I'm going to follow my own pattern. Case 1 is copy without the absolute value. Oops. Copy without the absolute value. That's what we did. Case 2 is recopy, but change the sign on the right side. Did I not say that over and over again earlier in this lesson and last year? That's what you do. So you copy without the absolute value, then you recopy, but you change the sign on the right side. You notice that was positive 2, now it's negative. That was negative 3, that's positive. Change the signs. Now I've got stuff to do, and there's some work to do here. For sure there's work to do here. A good bit of work to do here. Somehow we got to do this though. So I think I'm going to throw the 3 over here and make that 11, and throw the y over here and make that y. And so one of the answers is 11. I'm going to do something similar here. I'm going to throw the 3 over there and make it 5. I'm going to throw the y over here and make it a negative 3y. So y ends up being a negative 5/3. I don't think you saw that coming, but there it is. Now here's the problem. And I got the hint of it up here at the beginning, but here's the problem. We got 2 answers, but only one of them work. And the reason why is because that little detail I mentioned earlier about the extraneous or extra solution. Sometimes that's what happens. So what we need to do is get used to checking. Even though we didn't do anything wrong, we need to get used to checking to make sure that the solutions we get work. And so we put the 11 in here. I'm just going to do that. Put the 11 in here. We get 11 plus y, which is 19. Absolute value is 19. And put the 11 in here, we get 22 minus 3, which is 19. So that one checks. But when we put the negative 5/3 in there, it doesn't work. It just doesn't, not just because it's an ugly fraction, but it doesn't work. And you can plug that in and see that for yourself since it's an algebra 1. Oh, here it is. If you want to see it, they got their 2 solutions. They tried to check, and they got a positive 19/3 equal to negative 19/3. They went through the process, but there it is if you want to pause the video and look at it. So since that didn't work, then we realized that negative 5/3 is not a solution, so the only solution is 11. So it's already isolated. So the equation, the absolute value is already isolated. So I'm going to copy for case 1. And then I'll do case 2. Case 1, I copy, like I said, without the absolute value. Then I recopy, and I change the sign, and I change the sign. I think I take the 2x over there, bring the 5 over here. I bring the 2x over here. It'll be a plus when it gets over there. Take the 5 over there. Divide both sides by 5. And then I would check it, and you can see that only one of those is a solution. I'll let you work through that.